I am moving tomorrow. I'm starting a road trip. I got offered a job in Texas, so I am moving there to go do that job. I am definitely looking forward to being employed. Well, I've been trying to not look forward to things, but just take things a day at a time. But the idea of being employed again, having an income and all that jazz is very nice. Um, yeah, I had a thought about some of the topics I've brought up here on these videos, particularly the difference between holographic and linear encoding of information in a medium, be that art or a hard drive, or whatever. And I realized that I think I failed to notice and therefore point out one of the key and I think most important differences in um, systems that have the dispersed encoding of the holographic principle versus the uh, serial encoding of linear encoding, is one of the great features of linear encoding is that you can see where things went wrong if you get a wrong answer or a wrong, something is uh, funky. You can identify, this is the exact step it went wrong, rather than there being a diffuse um, error that could exist in part in multiple places, in something that has diffuse information encoding. For example, if I do a math problem wrong, if I fail to carry a one, or I fail to put a minus sign when I should have, um, and it leads to a wrong answer, I can look and I can say, this is the step where I went wrong. I can fix that. That's very clear. Where if, let's say, I write a series of poems trying to convey a mood, and I convey a different mood than I intended, it's very hard to say, this is the spot where the mistake was made, because it's not, it just don't work like that. Um, and I, this plays into something of, I think, how math is taught, because mathematics, if you're working off of, let's say, Euclidean mathematics, built on Euclidean geometry, you have a series of premises, and then you can use operations on those premises to come up with to use that as a foundation to build in subsequent steps a field of mathematics on top of it, or at least the consequence of that field of math. I actually don't know the technical terminology for. I guess those would be theorems. Yeah. Oh, yeah. Yeah. Haha. I do know that terminology to come up with the theorems that result from a set of axioms. But math is often not taught that way. I find logic is taught that way more commonly. Often math is taught by, um, okay, here's some examples. This is some examples of how this works. Now you've seen it enough times, so you should get the gist of it and go ahead and do it. And if you do it wrong, we're just going to say, you did it wrong. Here's some more examples that are similar. Do it right. And that is using non using nonlinear encoding, using kind of the holographic principle of, well, here's just a bunch of examples, and each one contains the information that you need, but putting them all together gives you a general kind of vibe of, you get it, right? You just keep doing examples and you'll get it eventually. The intuitionist model of mathematics, which, especially pre Euclidean, was how math worked. You did it a bunch of times, and then people were like, well, every time we work on this, it seems to come out with this answer. So, I guess it's kind of the inductive method of, well, every time we do this equation, it seems to result in this, therefore, that's the correct result. Anyway, my point is, it's hard to correct. It's hard to notice if you're being duped in or there are errors in nonlinear holographic encoding. And wow, yeah, if you haven't watched the previous videos, this is going to make no sense.